So in the last video, we've seen that the pop force is very important because it can create a unified, one directional force. But more importantly, on top, you can add a curl noise to make the whole thing more interesting. And of course, you can combine them, but you can also use the curl noise function by itself to add chaos to your existing simulation. Now, there's a very similar node to that pop force, and that is pop wind. And at first, they're almost identical when you look at the settings here, because it also has, it's not called force, but wind velocity, a direction. So if we connect that and put in 300 like before, we also get a unified linear direction. And also the pop wind has built in down here a noise, which is also a curl noise that you can add to the existing simulation. So basically it's kind of the same, but there's one very important difference, and that is that the pop wind is not constantly accelerating, but the numbers that you put in here define a target speed. What does that mean? If we look at the pop force with just a directional speed of 300, and we then look into our velocities, then you can tell that the velocity in x is constantly accelerating way beyond the 3 that we set here, because that is the speed that we're accelerating with. But if we try the same thing with a pop wind, and let's turn off the noise for now, that you can see that the x is not accelerating constantly, but slows down at the end and, tries to reach the 300. So what this number here is representing is not a constant acceleration, but a goal that the points are trying to reach. And this is a very important distinction. Basically, the way you can think about it, and this is why it's called pop wind, if you take a piece of paper, for example, and let it fly in the wind, then it will never be faster than the wind itself. It cannot accelerate beyond the speed that the wind has. Now, this concept of what a wind is in Houdini is actually also represented in other forces that we will see later on. For example, one force we will look at is called the pop curve force. We will talk about this later on. I just want to show you this here, tread as wind. This is a function that means it will do the same thing. It will define that the points that you accelerate with this thing try to reach a certain target velocity and will not constantly accelerate beyond that point. So this is an important distinction between the two, but both are very similar in that regard, that they can create directional forces, but also on top add noise. And you have to decide if you need noise or linear speed that can constantly accelerate your point, or that only should make the points reach a certain velocity. Now, the difference might not be obvious for you in the beginning, but this is actually something that you will notice later on makes a big difference, and it actually just feels different. So if we use the same numbers here, so both now use the same numbers, you can see that the pop wind feels very different to the pop force with this exact same numbers. One is constantly accelerating and the other one is trying to just reach a certain point. And the pop wind often feels a lot more natural, because basically what it also kind of mimics in a way is something like air resistance. Now, talking about air resistance, there's an interesting parameter here called air resistance. This, in my opinion, is very confusing, because air resistance implies that this number here only will slow down things, but that's not actually true. This number is actually more like a accelerator or stopper speed. So what do I mean by that? When you set your wind velocity to 0 and also your noise, then this means actually that the air resistance works as the name suggests, by slowing your points down. So if you combine the pop wind and the pop force, for example, one will accelerate the points. And as you can see here, the other one, the pop wind, is now fighting the points, because this air resistance means that's the strength. Those points are trying to reach that velocity up here, the wind velocity of 0. So here it makes sense. Now it works like a resistance. But if you turn off the pop force and put in a number here, like 600, so this becomes now, and maybe add a little bit of noise, classical, wind behavior, then here the air resistance means how quickly do those points try to reach those speeds that we set here. And I can prove that to you by increasing the air resistance. The points are actually much faster reaching the goal speed, not slower. So in this regards, increasing the air resistance here means speeding up the points more. So I find this naming here for this parameter really confusing. This is more like an acceleration number. The higher the number is, the more the points try to reach that goal velocity. By the way, that's also true for the noise. So both together will try to be reached with that. Only if the velocity is lower than what the velocities have, this can be considered a resistance. So don't misunderstand what this parameter means. It can be the complete opposite what you think it does. But in general, the pop wind again is very similar to the pop force. We can use it to accelerate points in a certain direction, but also, or we combine it with a curl noise that is built in. The big difference between the two is that the pop wind tries to reach a certain max speed, a target speed, and will not accelerate the points beyond that number. And the air resistance, with a weird naming, is the number that says how quickly do the points reach that point. And let me quickly show you that again in the opposite direction. By lowering that number, you can see that it takes longer for the points to reach the goal. So I hope this is helpful and not too confusing. Just keep in mind the pop wind and pop force are very similar, just the pop wind has a target and the pop force has a constant acceleration. That's the main thing you have to keep in mind. So I hope this is helpful. Thanks very much and see you later. Cheers.